So here's our cow eye. I'll start again. Here's cow eye. Here's the cornea. Here's some sclera, some white of the eye. All of this brown tissue feels like muscle. All this big, strong muscle hanging out around, that's muscle. I haven't removed a whole bunch of the muscle because I just wanted to get to the inside. You guys can remove it or not. Here is the optic nerve coming out the back. And so I picked this up and I was like, all right, the optic nerve is kind of pointed medially. Maybe this is a left eye, but it could be a right eye. It's really hard to tell when it's out of the body like that. This is what I'm talking about, the conjunctiva. So here we have this little film right here, and it kind of goes back and it makes a pocket. You know, it stops, and then it lays on the eye, and it stops at the edge, so it doesn't cover the clear cornea. So that is conjunctiva, which is cool. I've never seen before. And then, so that's pretty much the outside stuff: muscle, sclera, optic nerve, cornea, conjunctiva. And then we're going to go in. So I'm going to try to cut kind of closer to the cornea and not just in half. So I started with a really nice sharp scalpel blade, and I cut down. And then I'm going to try to kind of snip around with my scissors and see if I can kind of like...
Oh, those poor scissors.
Yeah, they're not the greatest. I might just use the scalpel because my scalpel blade is really sharp and nice. Michael was suggesting to me that I might use the scissors, but I don't like that, so I'm going to use the scalpel. And you know, you just want to kind of keep it level so that you don't cut crooked or roll it around. Oop, there we popped into the inside. All right. So you have two segments, right? You have a watery anterior segment where the aqueous humor lives, and then the vitreous humor lives in the back of your eye, and it's more like jelly. So I do see some liquid here. Some liquid's gonna pour out. That's some aqueous humor. That's a funny word, I hear you. There's an even funnier word, that the drain in your eye that kind of drains out excess aqueous humor when the pressure is too high, because it gets made and it circulates and it drains, and then it gets made by the ciliary processes, circulates and drains, is called the canal of Schlemm. And that's my favorite anatomy word ever, the canal of Schlemm. All right, so I'm just kind of cutting the whole front corneal area off from the back, the more posterior segment of the eye. All right, so we can kind of start looking inside. We see a little bit of a dark membrane pulling away. That will be choroid. Your choroid is the vascular part of the eye that feeds everything. Your retina is nervous tissue, so it's really energy intensive, or uses a lot of energy and needs a lot of food. All right, let's just keep going around, cutting off the front of the eye from the back.
Isn't that choroid the same as choroid plexus?
Yep. No. But the choroid plexus is a little vascular bundle of capillaries, and the choroid in your eye is the vascular layer. So they're both vascular, for sure. Having to do with, oh wow, okay. So, we open up the eye. Now we have, very, very nice. So you can see some layers here. You can see the white layer, which is sclera. You can see how the kind of this dark layer pulls away. The dark layer is choroid, the vascular portion. And then this yellow membrane that's pushed up on the back that looks a little bit like wet tissue, that's your retina. And so we have a really beautiful view right here of the optic disc. So this retina has all those nervous cells that send their little axons out to make the optic nerve, and they're all gathering together. Do you see this kind of gathering together right here, and then right here is where they're all exiting the eye, and that's going to become our optic nerve right here. So that's the place where you don't have any rods and cones, because there's just too many nerve bundles. There's no room for the layer of rods and cones. So if that's your optic disc, then that's kind of off to the side medially, then your fovea centralis and macula would be kind of in the middle of the back of your eye. And that, we can't see it or anything right here. You can see it in a picture, or when they shine a light in your eye. In your textbook, there's a picture of a retina lit up, and you see all the red veins, and you can kind of see the macula there. It's a little circle kind of dense. It's not where all the veins leave, because the veins are using the same, arteries and veins are using the same kind of passageway as the optic nerve is. So it'll be off to the side of where all those veins kind of coalesce and exit. So this pretty yellow, the kind of gray yellow wet tissue paper is retina. Now behind the retina, that beautiful kind of blue pearlescent stuff, that is tapetum lucidum. And tapetum lucidum is the thing that allows cat's eyes to shine at you in the dark. And so humans don't have a tapetum lucidum, but lots of animals do. Cows certainly do. And what happens is, just like on the movie screen, there's black pigment kind of on the back to absorb all the photons and give a really good reflective surface. So you don't normally in our eyes, because we don't have a tapetum lucidum, the photons kind of go in and then they get all absorbed and they give all their messages to the nerves, right? In low light scenarios, like at night, if you're trying to catch that, is that fox moving is that wolf moving in the brush, you need to be able to have more chances at that light, because maybe the first pass wasn't enough photons to give you accurate information. So this tapetum lucidum is reflective. And that's why cat's eyes shine at night when you catch them just right at the right angle. And that allows the photons to kind of bounce around in the eye again and give those messages to more nerve cells so they get the message clearer. And that's what tapetum lucidum does. And it's this beautiful kind of colored blue pearlescent stuff. So the yellow is the retina. Where the retina gathers and exits is the optic disc. The fovea centralis is the bullseye in the middle of the macula, and that's where your vision is the best. The white stuff is the sclera. That's the fibrous tunic, part of the fibrous tunic, sclera and cornea. And it has to be tough enough, it's connective, hard connective tissue. It has to be tough enough for muscles to attach and pull your eye around. So we can pull that away too over here, like the tapetum lucidum and the choroid are all kind of one thing. So when I pull this away, I can kind of see that black vascular layer. So the black stuff is choroid. And your choroid and your iris are all kind of the same layer. So let's pull this guy out. So there's some jelly here. So some of that jelly is vitreous humor. This beautiful blob of vitreous humor, and it's there to help hold that white tissue paper retina on the back of your eye nice and smooth. So that's the jelly stuff is your vitreous humor. Now up here, this hard thing right here is your lens. And typically this would be clear, but the fixation process makes it all cloudy. So this is the thing that changes shape to focus your eye for distance or close. And so this will have little tiny ligaments that stretch, that radiate out from the sides all the way around, and those attach to the ciliary body. And then they will kind of loosen to make your retina rounder, or they're tightened to make your retina, or not retina, pardon me. They'll loosen to make your lens rounder, or they'll tighten to make your lens kind of flattened. And that will shift the quality of vision for distance and close. And so, maybe there's some, funky suspensory ligaments hanging out in there, but I can't see them. There's no little ligament hanging off that I can see. That's a microscopic structure. All right, so now we're in the front of the eye. And we're looking out through the pupil. So the cow's eye pupil is kind of oval. So pupil is the absence of something. It's a space, and it gets smaller or bigger. So it's not really something you can pin. Typically when I have tested on a cow eye, if I put a pin here, I'm looking for cornea. I'm not looking for pupil, you know? Cornea is the kind of glassy, clear outer layer. So on the inside, we have that pupil. Around the pupil is the iris. So on your cow eye, the iris is kind of flat and shiny and black. Around that flat, and that's what makes the oval shape. Around that flat, shiny black thing, you'll see kind of a radiating flower pattern. That radiating flower pattern is the ciliary body. So ciliary body here, iris is flat, no texture. The kind of the flower texture or the spoke texture is the ciliary body. Ciliary body, iris. Ciliary body, iris. Ciliary body, iris. All right, sclera, cornea, ciliary body, iris, vitreous humor, lens, yellow tissue papery retina, optic disc, beautiful pearlescent blue tapetum lucidum, black choroid. On the outside, you'll see your lovely optic nerve coming out, and you'll be able to see a lot of the muscle tissue attached that pulls your eye around. And that, oops, yeah, I just messed up my beautiful retina. But you can still see the neat little optic disc where it all exits. So when you're seeing, light has to come through a bunch of cells. It's going to go through some ganglion cells, and it's going to go farther, it's going to penetrate, and it's going to go past the bipolar cells, and then it's going to hit your rods and cones. Your rods and cones are going to get activated, and they're going to send a signal back out through that tissue, through the bipolars, through the ganglion, and then into those axons that all gather together and exit the eye at the optic disc, where you have no rods and cones. Any questions about that? It's pretty